Hey guys, welcome back to another video in the Deep Learning with TensorFlow series. In this video, I'm going to teach you guys about TensorFlow datasets. Alright guys, so in this video, we're going to go over the tf.data subpackage of TensorFlow. It's a sub API or just an API within TensorFlow that allows you to work with data, bring in data, import it into your projects, and also pre-process them, and just basically set up a input pipeline is what they're called to pre-process your data and also feed them into a machine learning model. Now, up to this point, we've been bringing in our datasets using Keras by using the Keras built-in datasets and bringing in datasets like the MNIST dataset, the IMDb dataset, stuff like that, right? But what if you want custom data? What if you want to bring in a dataset that's not part of Keras or TensorFlow, or you just have files on your computer that you just want to import, right? So besides allowing you to import datasets into TensorFlow, the other thing about this API is that they also have really good performance. They're optimized for performance and they're very efficient. The reason is because if you have a very large data set that cannot fit into your computer's memory directly, what this allows you to do is whenever you're using these data sets within your models, it will bring in only as much data as it needs. For example, in terms of efficiency, another thing that they can do is prefetching, which means that while your model is training, it can do it one batch at a time usually, right? It's going to forward propagate a batch through your model and then do back propagation to adjust the weights for that batch, right? But while that's happening, TensorFlow can already be taking the next batch and processing it into memory and pre-processing it to get the data into the form that it needs to be sent through the model. So while the model itself is training on your GPU, it could be pre-processing the next batch of data on your CPU, for example. It's just those kind of things that this library can do that really makes this very powerful. So the main component behind tf.data is the dataset, which is a class or an object that represents a collection of data. So they're used to feed data into a machine learning model, train it and all that stuff. And it can come from many sources like CSV files, image files, TF record files, NumPy arrays, tensors, Python generators, all kinds of different formats. And you can use these data sets in different ways. You can transform them, you could shuffle the data within them, you could do batching, all kinds of really cool stuff to build a data pre-processing pipeline for your project. Overall, though, this is how we're going to be able to create custom data sets for our project and also do data pre-processing for our projects, okay? So it's important that you know what this is. So in this video, I'll be teaching you the basics of how to get started with these data sets and tf.data. There's a lot to it, though. This is a pretty big and extensive library with lots of different things that you can do. So I'm not going to go over every little thing, but I'm going to give you guys hopefully enough so that you know the basics of what to do. So whenever you need to use stuff like this, you know what to do, okay? So if a dataset is a collection of data, how do we create one? There's two different ways you can create a dataset. That's either by creating it from a specific data source, like a tensor, for example, or you can create a dataset from another dataset. So let's start with the former, which is creating a dataset from scratch from a source of data. We can do tf.data.dataset, and then now we could do something like from tensor slices, for example. So you can literally just pass into this function here pieces of tensors. So basically just a list of numbers would work. So 1, 2, 3, 4, 5, 6, 7. So 1 through 10, for example. So now we've created a data set, and the elements of the data set are going to be each of these individual numbers here. We can take a look at what a data set contains by doing list, and then dataset.as numpy iterator, like that. Now if you run this, let's see what we get. There we go. So we've taken our dataset, converted it to a numpy iterator, which basically just gives us the values of the dataset. So we print it out, and here we go. So it's just 1 through 10, basically. So that's just one way you can create a dataset. You can also create a dataset using a numpy array, very similar. So we have a numpy array data variable here. We're just going to pass it into the same function that we used before, and we get the same result. You can also create a dataset by doing tf.data.dataset.range. And just like the normal Python range function, if you do range 5, it'll give you numbers 0 through 4. Or if you do 2 and 5, it gets you 2, 3, 4. So if I do 12, I get 0 through 11. This is a more realistic example. So usually we're going to have our datasets put into features and labels. So for the feature tensor, this is basically a matrix. So you have 2 columns, so boom and boom for each of these. And then you have 3 rows, 1, 2, 3. And so for each of these elements of this tensor here, you have 2 features, this one, this one, this one, this one, this one, this one, okay? So you can imagine this also as the X matrix. And then we have our labels tensors, so cat, dog, and fox. So you can imagine that this is maybe a data set for classification, so we can make a model to classify data. So to build a data set out of this, we can do dataset is equal to tf.data.dataset.from tensor slices. And then now make sure you do it like this. Features, labels. So what this will do behind the scenes is automatically split up the data based on the first dimension of all the different tensors that you pass into it. So this row will go with this label, this will go with this one will go with this one. It's all automatically done based upon the first dimension. There we go. So when we print the data set, we can see that this data is now matching with one another like that. So hopefully this is making sense so far. It's just important to show you that there's different ways you can create data sets from all different kinds of data sources. Another more realistic example here is creating a data set from a CSV file. So this is a CSV file stored at this location here, but Keras has a utility function that will get the file from wherever it's stored and basically download it locally as this file here. So this will download the file from here and put it into this file. And then now we have a variable to reference it from, and then we're going to read into a pandas data frame, and pandas is actually very common for data preprocessing. And then after that, we can go ahead and use the same exact function from tensor slices. All we have to do is convert the data frame to a dictionary using the dict function, and this will automatically know how to basically take it in and add it to the data set, and then create a data set out of it. Here we go. It's kind of hard to kind of tell what's going on here, but we have these dictionaries of the columns mapped with their values, but it is inside of the dataset, which is great. I'll give you guys another example real quick using the MNIST dataset that we've already worked with. So even though we're doing curious.datasets.mnist to bring in the MNIST dataset, these are not the same as a tf.data dataset that we're learning about right now. Even though it's called a dataset, it's not the same thing. So when we do MNIST and then MNIST.load we're basically just getting the NumPy arrays. We're not actually getting a dataset object. So sometimes what you will like to do is take these NumPy arrays from these datasets they're importing and actually convert them to a TensorFlow dataset, because you may want to do further preprocessing. And like I said before, tf.data datasets allow you to do preprocessing more efficiently. So just as an example here, we're creating both a training dataset and a test dataset out of MNIST that we've imported through load data. So we're using the from tensor slices function to bring in the X train and Y train, and we're matching them together, and it's automatically going to slice it up and match the rows with the actual Y values and such, and same thing for the test as well. Okay, so those are a few different ways that you can create data sets out of data. So we have a list here that we're passing in basically. We have NumPy arrays, we have using the range function, we have actual tensor constants, we have CSV files that we're importing as data frames that we're then converting into a data set. And then we're also using a Keras data set, taking the NumPy arrays and making two data sets out of that for training and testing. So all of these are just common ways that you can create datasets with tf.data. There are a bunch of other ways you can do it because there are a bunch of other data formats, but this is enough to get started. So once you have an actual dataset, what can you do with it? One thing that we learned is important is being able to actually view the data, which we can do with this list function here. So we're doing dataset.asNumPy iterator and passing it to list, which will just print all of the information all at once. But sometimes you might just want to iterate through the dataset itself, just element by element, which you can do by doing a for loop, because the dataset actually is an iterator behind the scenes. So for example, what we can do is do for item in dataset. So now item is an individual element of the dataset, or individual row, you can think of it as. We can do with that whatever we want to. We can print it out, for example. So item, and we just get a bunch of tensors, right? If you want to, you can convert those tensors to the actual numbers that they're backed by doing NumPy. There we go. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So with this example here, where we had both a features tensor and a labels tensor being matched together essentially, and creating a dataset out of that, we can also iterate through those contents and print them out. So if I run this and then try running this one, I get an exception because now it says tuple object has no attribute NumPy. So now that each element of the dataset is not a single tensor or a single value or something like that, instead it's a combination of both a feature and a label, it's going to be a little more complex. The data type of item is not going to be just a single tensor, it's going to be a tuple with the tensor for the feature and the tensor for the label. So let me go ahead and show you what I mean. Let's get rid of this and try running it again. There we go. So now we can see that if you look very closely here, we have two tensors each time we're printing this out. So we have one tensor, which has the values 1 and 2, and then we have the second tensor, which is the label that has the string of cat, for example. So if you want to, you can pull the elements out of the tuple, from here, or you can actually do it directly in the for loop. So you can do, for example, feature and then label. There we go. So now we can see for each iteration of the elements of this dataset here, we're printing out the contents of both our features tensor and also our labels tensor. Obviously, it's really nice that it's keeping the features and the labels together in the dataset, especially when we process them like this, or rather iterate over them like this, because when you're actually training a model, you want them to be together, the features and the labels. So that's really cool. Another thing that you can do when iterating and accessing the data of a dataset is use the take function. So we can do, for example, dataset.take, and we can pass in a number like 5. What this will do is take the first 5 elements of this dataset and return as a new dataset. So now we're only iterating over the first 5 elements if you run this. So 1 through 5, 1, 2, 3, 4, 5. If you change it to 9, obviously it'll only get 1 through 9. If you change it to 2, there we go. That's very helpful if you just want to access a small portion of the data instead of iterating over the entire dataset all at once. So I mentioned before, the only way to get a dataset is by creating a new one from a data source like we've done above, or by creating it from another dataset. The way that you do that is with transformations. So on datasets, you have a bunch of functions like shuffle, you have batch, you also have mapping. These are functions that you can call on a dataset, and usually they'll do some sort of transformation on the data, and it returns to a new dataset that you can use. For example, we can do batching. So we could do batched dataset is equal to dataset dot batch, just pass in the batch size. So just as a refresher, a batch is basically a way of combining the elements of a dataset. So right now, by default, this will have a batch size of 1, so each element is just by itself. But when you set it to a batch size of 3, for example, it will combine it into groups of 3. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And since this is the last one, it'll just be by itself. So if there was an 11, it would be 10 and 11. If there was a 12, it would be 10, 11, 12. So it'll just try and group it to groups of 3 as much as it can. Batching is useful for machine learning when you want to train on multiple examples at once, which obviously can be more efficient because you take advantage of parallelism, but also you don't have to load each individual element and process them one by one. By combining the elements together into groups, as we're doing with batching, we can make our training process a lot more efficient, we learned. And it should also be data set, not data, just like that. Now we can see that instead of printing out each element one by one, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, it's doing it in batches. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10, because there's no other elements to go with that. If we set our batch size to 7, for example, let's see what that looks like. So now we have 1, 2, 3, 4, 5, 6, 7, and then we have a leftover batch that tries to fill up to 7, but it can't. So here's what batching looks like when we have our tuple of features and labels. It looks a little weird when it prints it out, but basically we're importing it the same way, creating a dataset out of it. Then we're making a new batch dataset by using dataset.batch and setting the batch size to 2. And now we're going to iterate over that batch dataset and print out the batches. So the first batch has features 1 and 2 and 3 and 4, but also that's going to correspond to 2 different labels, so cat and dog. And then the next one only has 5 and 6, and then fox, because there's only 3 total. So obviously the next batch won't fill up to 2 all the way. Another way that you can commonly transform your dataset is by shuffling. So we could do dataset is equal to dataset.shuffle. And to this, you can pass a shuffle buffer size, which I'll explain in a second. So we can do, for example, 10 for now. But once you shuffle your dataset, which as it sounds means to rearrange the elements of the dataset, let's take a look at what that would look like. So now instead of 1 through 10 in the actual order that you pass it into the dataset, you can see that since we've shuffled it, it's now in a completely random order. So the way that shuffle works is pretty interesting. You can look more into this if you want to understand more about it. But basically what will happen is you create a buffer of the size that you specify. So a buffer is just a temporary container to hold elements. So if I set it to, for example, 5, what this will do is whenever I call this function, it will fill up the buffer with the first 5 elements. So 1, 2, 3, 4, 5. So then to actually create a new shuffled dataset, what it will do is randomly select elements from that buffer. So it's just going to choose a random one from that buffer and then replace it with the next available element from the original dataset. So again, if our original buffer size is 5, it's going to first choose these ones here. That will be inside the buffer. Then it's going to choose an element from that buffer, like for example 2. So if 2 was chosen, that will be replaced with the next available element, which would be 6. And then again, you're going to randomly sample an element from the buffer. It's a little confusing, but hopefully that makes a little bit of sense. The whole idea though is that basically you want to have a higher buffer size. The higher your buffer size is, the more perfect the shuffling is, so to speak. It's going to have it's going to be more random. Ideally, you want to have the same size as the actual size of the dataset itself. So if our dataset size is 10, we should set the buffer size to 10. The thing is though, obviously you're going to have much larger datasets than only 10. So you can have a dataset with, tens of thousands or hundreds of thousands of elements potentially. So you want to choose a buffer size that is more reasonable. It really just depends on the resources of your computer, of your machine that you're running this on, because the higher your buffer size is, the higher amounts of memory is going to be used, okay? So just in general, you want a higher buffer size, but not too large because you're going to use too much memory, okay? So if I rerun this, it's going to shuffle in a different way each time, so it's random. You can give it a seed though, actually, so you can set a seed, which will basically make it so that it's going to choose the same random, quote-unquote random set of elements each time. So if I rerun it, you can see that it's not changing. What's also cool about these transformation functions I'm teaching you about is that you can combine them together. So for example, we can go ahead and shuffle our dataset and then also batch it right after. So we want to randomize the ordering of our elements, and then we can also still batch into groups of 3, excuse me. So the last transformation function I'll teach you about is the map function. So if we have a dataset and we could do dataset is equal to dataset tf.map. What this allows you to do is take each element of your dataset and transform it to a different type or just a different value, whatever you want to do. But basically, you can apply a function onto each element. So for example, we can do lambda x times 2. So we're providing this inline lambda function to this map function, which will tell it that each element of this dataset that we currently have, we just want to multiply by 2 and replace. If we get 2, 4, 6, 8 instead of 1, 2, 3, 4. What I want to do now is give you guys an example of an actual data pipeline, which means that we're going to be setting up the actual importing of the data into a dataset and then pre-processing it. This should help you solidify what we've been learning so far because you'll actually understand how it's useful. All right, so we've got a dataset online on storage.google APIs. It's a TensorFlow dataset called flower_photos. So what this utility function from Keras will do is actually download this zip file from online and unzip it automatically and put it into this folder here. And then this piece of code here will actually get the file path that we can then use to import the data. Let's actually do that. So we're going to do list dataset is equal to tf.data.dataset. And we can use this list files function within dataset, which will take a string, and we're going to use our flowers root, which is an object, flowers_root, and we can add on to this star. I know this is kind of weird looking, but what this will do is basically take our root file path for this dataset that we've downloaded here, and then this will basically tell it which folders it can access data from. And the stars here will make sure that it includes all files in the subdirectories of this root directory here. Here we go. So we can see it's a bunch of strings. So we can see that we have a root dataset folder here, and then within that we have a daisy folder, we have a sunflowers folder and a tulips folder, which are the different classes that this dataset contains. And then within those class folders, we have actual pictures of flowers that we're going to use as part of our dataset that we're going to be using. So if this dataset only contains the file paths for the images of the dataset, obviously we want the actual images themselves, not just the file paths. So now what we can do is use our mapping function to transform each of these file paths here into an actual image. Again, the mapping function is useful for a couple of different things, but it can be especially useful to convert one data type to another. I'm just going to paste this code, but this is the function that we're going to use in our mapping function. So this is going to take in a file name, which is just going to be one of these. So first it's just going to extract the label from this file path, so it can be daisy, sunflowers, or tulips, for example, because it's separated into different distinct folders. And then what it will do is load the actual image itself. So it's going to take the entire file name and then read the file, decode the JPEG, convert the data to Float32, and just resize it to the uniform size of 128 by 128. So again, this function here extracts the images themselves and the labels for each of the images. So now let's go in and apply it to our dataset that we have. So we can do images dataset list dataset dot map, and then we can just pass in our function. So parse image. So now each element of our list dataset will be passed into this parse image function, which will then spit out the tuple of image and label, which now makes up this new images dataset. So you can clearly see how we're building this, data pre-processing pipeline. So let's just take a look at a single element, for example. There we go. So we can see that we have an image shape of 128, 128, and 3 because it's a color image. And then the label of that first image is a dandelion. So now we can do other stuff like shuffling and batching, for example. So images dataset is equal to images dataset dot shuffle. And we could do a buffer size of, let's just say, 1,000, because we have a lot of elements inside of this. And then we can go in and batch it. So batch, and then 32. That's a pretty standard number for batching. Something else that you may commonly see is splitting up your dataset into a training test set and a validation set. This is just one example of splitting up your dataset into a training and test set. You can see that 70% of our set will become the training set just by this piece of code here. All right, so now that we saw an example of how to bring in a dataset, download it, import it, and pre-process it, now I'm going to show you guys a full example of how to take our MNIST dataset downloaded from Keras, convert it to a tf.data dataset, and then do a little bit of pre-processing, and then finally feed it into a machine learning model to actually train a model. If you're using a dataset, it's a little bit different than how we usually call the fit function. So from this load data function, we have this xtrain, ytrain, xtest, and ytest NumPy arrays. We're going to take that and convert it to a training dataset and a test dataset just by calling this piece of code here from tensor slices, passing both of these together, and that will be combined. Now we want to do a little bit of pre-processing. We learned before when we made a classifier for this dataset here that we need to make sure that each of the pixels of our dataset is normalized between the range 0 and 1, because by default the values are going to be 0 to 255. So we just want to make sure it's a smaller number range that is normalized. And we could do that just by dividing each pixel by 255. So this piece of code here will do that. We're going to call the preprocess image function. It's going to take in an image and a label. For the image itself, we're going to cast each of the pixel values to a floating point data type, because that's what we need for a machine learning model. And then we're going to normalize it by dividing by 255. So that will do all of that. And then we're returning the image and label back. To actually call this function, we're going to call it on both the training set and test set using the map function. We're just going to pass in the function that we want to map it with. The reason that it accepts a image and a label as separate parameters is because each of the samples of our data set here is going to be a combined x and y. So that's going to correspond to the image and the label. So whenever you actually map it, you need to pass in both of those. And so that will do it. The next thing that I want to do is going to shuffle it just to make sure that the data is randomized and shuffled. So we can do train dataset is equal to train underscore dataset dot shuffle. And we could choose a fairly large number. Not too big. We'll just do a random number like 1024. That should be decent enough. And then we also want to batch our set. So we're going to do batch 32, which is a standard batching size. So now the question is, how can we take our preprocessed dataset and feed it into a machine learning model and train a model based on the dataset, right? So first of all, we need a model itself. We'll just use this right here. So we're building a sequential model. It's got our flatten layer. So we're going to flatten it from 28 by 28 to just a single vector for each sample. And then we're going to have two hidden layers. So the first one's going to be 256. The second one's going to be 128 neurons. And then we're also adding some dropout. So this is all pretty standard, I think. Now we're going to compile it. We're using Atom and sparse categorical cross entropy because we're doing a single label multi-class classification problem, and we're not doing one hot encoding. I'm also going to add early stopping to this to make sure that we stop it whenever it starts to detect that it's overfitting by monitoring the validation loss, which we learned about before. Okay, so to actually train the model, we can do history. It's equal to model.fit. Now previously we would pass in the separate x train and y train numpy arrays, but since we have it in the form of a dataset now, a tf.data dataset, we can simply pass in train underscore dataset, and that's perfectly fine. That will have the combined x and y as we know, so we can now add our epochs, which is we'll do 25, and then now we can add our callbacks, and we'll just do our early stopping callback like that. So you may notice though that we're not providing our validation split like we usually do. We usually do a validation split of 20%. So this will take 20% of our training set and set it aside for validation testing during the training process. And we also are not providing our batch size like this. This is because when you provide a dataset to your fit function, you cannot use these parameters. First of all, the batch size is something that you specify when you're actually using the dataset. So we call batch right here. So that's going to be defined within the dataset itself. So there's no reason to put it here. And then the validation split we cannot use because it does not automatically take a validation set from the training set that we pass in. We have to pass in the validation set ourselves. So what I'll do is get rid of this. And now back up here, before we batch it, we're going to split our training set into a training set and validation set. So this piece of code here will do that. We're just defining the split, so 20% of our training set. This will then calculate the number of elements that we'll need for our validation set to meet that 20% threshold. So we'll do training set.take and then however many we need. And then we'll also take the rest of it for our training set. So now we have a separate validation set and a training set. So then we'll go ahead and batch it to 32 afterwards, like that. So now down here, we can now provide our validation data, val dataset. So now when it's fitting the model on the training set, it's also going to validate the data on our validation set as well, okay? Just like before. So hopefully this whole process is not too confusing. The main thing to know is that you can provide a dataset to your fit function. As long as you understand that you cannot provide a validation split, you need to provide the validation dataset yourself. And also you cannot provide the batch size. That is something that you specify yourself in the dataset itself by doing .batch. All right, the model is finished training. Now we can go ahead and plot the validation loss and training loss and also our accuracy. Here we go. So we can see that it started overfitting about 10 or 12 epochs. But then if we look at our validation and training accuracy, we can see that we have really, really high numbers. We're peaking at about 98%. Really great overall. I really hope all of this made sense. Just the whole idea of taking a data set, importing it via the different ways that we learned about, and also pre-processing the data in different ways using the different transformation functions such as mapping, shuffling, batching. There's other ones out there, but those are the most important ones. The very last thing I want to show you real quick is how you can prefetch data. So up here when we batch the validation set and the training data set, we can add on to this and we can go ahead and do prefetch. Into this, you provide a buffer size similar to shuffle, which will fill up a buffer of however many batches you specify. So basically the way that this works is while your model is training on a specific batch, it's going to prefetch however many batches you tell it to prefetch so that it's ready to go immediately. That way you can utilize your GPU for training and then have your CPU at the same time pre-processing and getting the next batch of data ready to go. So you can provide whatever number to this you think makes sense. Depends also on the amount of memory that you have on your machine. But one of the things that you can do is to tf.data.autotune. Doing this will just set it to whatever TensorFlow thinks is the best amount. Again, this really underscores also how datasets are better than otherwise, because if we have a really large dataset, we don't want to load all of that into memory all at once. We want to, split it into batches and do one batch at a time, maybe prefetch some batches. But the whole idea is that you're not loading the entire dataset and preprocessing it all at once, because that can be very resource intensive. With the TensorFlow dataset API, we can have a pipeline where we're preprocessing and training and doing things step by step, but also in parallel so that it can be more efficient. So hopefully that all made sense. This is just a taste of how we can use the TensorFlow data API to bring in our own data or just pre-process data in general, and then also make our data pipeline more efficient by doing stuff like prefetching or training a model on a data set. So if some of this is still a little bit confusing, don't worry. We're going to be using this in the future episodes, especially when we learn about data augmentation, because it's going to be part of our pipeline. Thanks for watching, everybody. Peace. So that's it for this video, everybody. I really hope you learned something new. If you liked the video, please hit the like button, and if you want to see more, hit that subscribe button. Make sure to also check the description below for important links to code and other resources, but also really important, join our Discord. We have a big community of over 5,000 programmers, and it's a place where you can find new friends or get help on any code that you're stuck on. If you want to support what I do on this channel, please consider hitting the join button below, and this will allow you to support my channel for as low as $1 a month, but there are different tiers to choose from if you want to. For anyone that becomes a member on my channel, you get a special rank on my Discord server, early access to new videos, and you can just see yourself on the screen right now. So if that sounds cool to you, feel free to join. If you don't want to, that's fine. If you can't, that's okay too. I really just appreciate you watching the video anyway. Thank you so much. And that's it. Peace.